Solving two-step equations, notes. So today we move from one-step equation solving to two-step equation solving. So we're just going to add one more step, okay? So here's our equation. We have 2x plus 5 equals 19. Now, in one-step equations, we would have just had the x plus 5, and we would have had to subtract 5 from both sides, or we would just have 2x and divide both sides by 2. But now we have both happening at the same time. We have addition and multiplication. So of course the question would be, which one of those do we get rid of first? Well, we turn to the order of operations, which remember is PEMDAS. And when you're solving, we always do the order of operations in reverse. Okay? So we actually start by getting rid of any addition or subtraction. Then we get rid of multiplication or division. Then we get rid of parentheses and exponents. So in this case, I have plus 5 and times 2. So I'm going to get rid of the addition or subtraction first, so I'm going to get rid of the plus 5 by subtracting 5 from both sides. Those cancel, but the 2x stays there. And 19 minus 5, of course, is 14. Now it's just a one-step equation. And since I multiply them by 2, I simply divide both sides by 2, and I get 7. Again, we could plug that number into the equation for x to make sure we're right. So 2 times 7 would be 14, and 14 plus 5 is 19. For example 2, we have 3 times x minus 10 equals 20. Again, doing the order of operations in reverse, I'm going to get rid of addition and subtraction first. So I have to get rid of minus 10 by adding 10 to both sides. And you can draw the line again if you want. Those two cancel. I still have 3x on this side. 20 plus 10 is 30. And then of course I would divide both sides by 3, leaving me with x is 10. And again, you can check your answers. If you plug the 10 up here for x, it'd be 3 times 10 is 30, minus 10 is 20. And I know I'm right. Here's another example. Again, I'm going to get rid of addition or subtraction first, so the plus 6 I will get rid of by subtracting 6 from both sides. The negative 4x just comes down and stays the same. 26 minus 6 is 20. Divide both sides by negative 4. Those cancel, end up with negative 5. Remember, a positive divided by a negative is negative. For this example, of course, I'm going to get rid of the adding 12 first by subtracting 12 from both sides. The negative 5x stays here, and the negative, of course, is still there. Negative 23 minus 25 is negative 35. Divide both sides by negative 5. The answer is 7. On the back of the notes, there's a couple more examples. Remember, the slash means division, so this could be written this way as well. I still get rid of addition or subtraction first, so I'm going to subtract 7 from both sides. The x divided by 3 stays there. And then the opposite of dividing by 3 is multiplying by 3 on both sides, which gives me x equals 9. Another division problem. So the first thing I would do is add 9 to both sides. And x divided by 5 would be left on this side because those cancel. And negative 21 minus 9 is negative 11, negative 12. Yes. Then I'm going to multiply both sides by 5 to get rid of that. And I would get negative 60. The last example, just want to do one with tons of negative signs. But again, we get rid of addition or subtraction first. So I'm going to add 12 to both sides. And if you need to use a calculator to do some of these, that's totally fine. That would be negative 91. And then I'm going to divide both sides by negative 7. and negative 91 divided by negative 7 is 13. And recall that a negative divided by a negative, of course, is always positive. So just keep in mind, on two-step equations, you follow the order of operations in reverse.